Hello, I'm Roger Fawcett, CEO of Omnitek, and in this video I'm going to talk through Omnitek's ISP IP. So in this block diagram here, you can see the key blocks of the ISP block. So on the left, you can see the image cropper, then we have a defective pixel correction block, we then have a black level compensation block, followed by a vignette correction block, an auto white balance and a color filter array. So in this block diagram here, you can see some additional processing to capture statistics from the image such as histogram and average levels, which are used to automatically control the previous processing blocks. So the ISP can also be used in conjunction with other Omnitek processing IP, such as our warp IP for camera lens correction, for example. It can also be followed by our OSVP processing IP for scaling and other color correction. And finally, with the combiner, you can key over a graphic overlay or other video feed. So in this diagram here, you can see where we've used our ISP in a larger design, in this case an image stitch design, and we've got 4 ISP inputs to take 4 camera inputs, which then feed into our warp and subsequent processing for image stitch. So in the reference design, we start with the raw camera sensor here. This is actually encoded onto CoExpress and sent over a CoExpress link. So we're sending the raw Bayer without any processing over the CoExpress link, which incidentally provides power and control, so it's a very convenient camera extension. So in the KCU105, the Xilinx FPGA then receives the Bayer feed over the CoExpress link. It then feeds that into the ISP for processing. We also, in this design, use our combiner to key over a graphic which is fed over PCI Express, and finally the output is displayed over an SDI link, and you can see the output here. A key part of the processing chain is the D-Bayer filter, and you can see a block diagram for that here, which converts the Bayer array into a regular RGB raster array. So now to talk through the ISP processing blocks in the chain one by one. So first of all, on the left in the block diagram, you can see the image cropper IP. And here we can see the effect of that, applying the image crop to select a region of the image appropriate to the output. We then have a defective pixel correction block. So we're demonstrating that here by inserting some defective pixels onto the stream to illustrate the effect. And then if I apply the defective pixel correction, you can see this detects where these pixels are and automatically removes them. Okay, the next block is the black level compensation, which I'll demonstrate with the automatic gain control. So you can see the raw output from the camera here, which obviously the colors are darker and not correctly balanced. And if I apply the automatic correction here, you can now see the correctly set up image. But this image still has the wrong RGB gain levels, and if I apply the automatic RGB gain correction, you can now see a clean image output. And this is currently set so that 5% of the image will be saturated. So for this particular scene, it's quite bright. But in these scenes here, you can see by adjusting the gain to the image or by adjusting the percentage saturation, I can tune the overall exposure of the image. So the Omnitek ISP includes a vignette correction block, which contains a mesh of different levels of gain control, which can apply a radial, for example, correction in gain, which I'll apply here to create an evenly illuminated scene.